Welcome. Thanks for joining me for Enterprise Workload Migration. Let's get started. My name is Brian Frome, and I am an Alliance Manager for SUSE. Here are the topics that we'll be talking about today. So let's go into the need for workload migration and a strategy around that migration. Here's a comment from a customer of ours on how Kubernetes is their floor, if you will. Beyond that, below that, if you will, it's overhead to them. They really don't want to have to manage the operating system and the stack below Kubernetes. And that's a very interesting thought about the complexity of IT and the need for workload migration. So let's talk quickly about application models. So in the traditional legacy model, we have a very monolithic stack approach where we stack software together and we build an application or a set of applications on top of that stack. And some of the aspects of this stack approach really leads to the need to test the entire application, right? If we don't really understand the dependencies between all the components in the stack, then there's no real good way to just test a change because we're not sure what it affects. So we have to test everything. And so that's expensive. It's hard to deploy that new change. What if we change one line of code? Can we just change that one line of code? Probably not. We have to redeploy maybe the entire site. So that's expensive as well. Often these monolithic applications run in a virtual machine, so that's good in terms of virtualization, and there's some flexibility there. But you have to stack everything on top of the operating system. And then replication happens by replicating the entire machine. And not only is that expensive from a computational standpoint, but we really don't get economy of scale where we just say, well, I don't want to replicate everything. I just want to replicate a piece. In the cloud native approach, we take what's called a microservice model approach, where we break the application into components, which are really services. And why are we calling them services? Because we call them through a web API. So they behave like a web service. We send a message to the API. The API runs some code that's encapsulated inside that component, and some result gets sent back through the web API. Why is that important? Well, that separates the dependencies between the components so that we know everything within that component is logically separate from the rest of the application. And the only way that we know how to talk to this thing is through its API. That encapsulation really leads to a much more flexible environment where I can change a single piece and know that I only have to test the interface to that single piece to be assured that the code that I have implemented or enhanced is working the way I would expect. And scale is really done now at a component level. So if I want to scale the order entry component of the application, I just scale that component. I don't need to replicate the whole virtual machine for the whole stack and do that as many times as it takes to get the application to run. I just scale the specific component that's needed to cover the load of the need for that we have to scale towards. So let's talk about migration then in the legacy approach. So when we migrate at the level of a machine, right? And why do we do that? Well, we often do that because the machine might be having technical issues. In the old days, that was actually hardware, right? Or maybe it was the operating system on which the application ran. Or maybe the machine is overloaded, right? It's the task that this application is doing is too much for that machine. And so we need to move it away from that machine and try to figure out what the problem is with the performance issues. Maybe we're repurposing hardware, or maybe the application today is better suited in a more logical location, like in the public cloud or by a managed service provider. There might be other reasons as well. So virtual machine application migration is certainly a very convenient virtualization capability because it's above the level of bare metal. At bare metal level, we have to move the whole operating system and configuration off of a machine and start over and redeploy the operating system. At least with a virtual machine, it's all bundled into an image for that virtual machine that we can just lay down in a new environment. And then there's this notion between virtual machines as pets versus components as cattle. And pets are really something you have to take good care of, right? You have to configure the operating system and the application and the stack a certain way and don't touch it after that. Versus cattle, where if their component has a problem, well, we just shut down that component and restart it, or maybe move that component to another machine. And that flexibility is really thought of as more like a cattle approach. We don't need to take special care of any one component. And one of the other aspects of pets versus cattle is the notion of being able to scale horizontally. So again, rather than scaling an entire machine from the operating system up, we scale components as they need. So the piece that has the most performance need can scale as it needs to. So let's then focus on application migration at the container level. So cloud native application models really give us an added level of flexibility and portability above a virtual machine. And that's because again, the floor, as our customer mentioned, is Kubernetes, or it's a container system, right? And Kubernetes is the orchestration of that container system. And when we think of that as the floor, then moving a specific component to another Kubernetes environment should be very straightforward. And we'll talk about the details of how that happens. So we move containers around based on the specific needs. Maybe we have dedicated hardware needs like a GPU or other hardware specific needs that the application has. But we can allow the system to do that for us. Kubernetes will place the components where it believes they're best located, and we can teach it to do that. Of course, we can tell it too. We can say, oh, no, I really want to run this piece here. And as I mentioned in the pets versus cattle approach, a component is really viewed as something that can fail, and often they do. So Kubernetes can take care of restarting components for us, and we can describe what we want when we think of restarting component pieces. And when we talk about maintenance of components in a cloud native approach, what we're really thinking of is that the application pieces themselves, as opposed to the whole stack from the kernel all the way up. Again, in a virtual machine, we have configured the kernel and the operating system a certain way. And so that pet approach really means that if we need to maintain that, we need to make sure that any new versions and things that we've implemented have to take that same approach, that we have to configure all the pieces the same way. Whereas a component approach is much more flexible. We can run a component on any environment. We're not concerned as much about the kernel configuration. That's a detail below the level that we want to think. So container runtime flexibility really leads us towards workload migration. So what does that mean? Really, again, what we're looking to do is move pieces of our applications, and often the entire application, but sometimes not, sometimes only pieces of the application, to the best location that's appropriate for our business needs. And that's an important aspect too, not just for the technical needs, but for the business needs. So some of these examples are, I just want to run it in the public cloud because it's better for my customer to run it there than it is in my data center. Maybe a workload is better managed by a separate company, by a managed service, because then I don't have to worry about the effort that it takes my staff to do that work. Maybe I want to burst occasionally. I've got a data center, but sometimes it becomes overwhelmed with the work that I'm doing in that data center, and I need to just move an application out into the public cloud or a managed service provider. So those are some of the workload examples where migration makes sense. And I really view this as workload migration should really be a business consideration. It should be a common consideration. We think of it in the past, certainly, and today as sort of something that we do in special cases, like I mentioned before, like, oh, there's some need to move the application off of this machine. But really, the things that I've just talked about, moving something to the public cloud or bursting to another environment or using a managed service, those should be business decisions. And when we realize we need that assistance, we just employ the technology to allow us to do that. It's simply and easily. So we'll talk a little bit more about what it takes to make that happen. But what you'll see is that automation is really key. And we'll talk about what that automation looks like through something called infrastructure as code. So let's talk about infrastructure as code a little bit. I promise there won't be a quiz. You won't have to worry about the code that I'm actually going to show you. It's quite simple anyway. These are just commands that we would issue to Kubernetes. So Kubernetes has the ability to take resource definitions and apply them to a Kubernetes environment. So that's what this kube control command is doing. And these are some examples of taking a resource, a set of resource definitions called a manifest, and applying it to our environment so that a specific application might behave a certain way. These are great. You can automate these top commands and put them into a script or into some sort of automation, but they're also somewhat low level. We'd like to move even a step farther in our automation. And there's a tool called Helm that really leads us in that direction, where we can bundle resource information together that begins to move us to a policy approach where we say, this is the policy that I want to define for my application. I define the resources that implement that, and I store that information somewhere in my company's uh, repository of known good infrastructure as code. And then I leverage that infrastructure as code to run my applications. And that's important because we want to be able to move an application easily for a business consideration. And if we have infrastructure as code that's implemented, then running the application on a new environment is as simple as pointing to one of these new components, resource definitions. So Helm is a real big step in that direction towards that infrastructure as code. Let's talk about another aspect of how we use Rancher then to assist with this workload migration. So we've talked a little bit about kube control, the command that we would use, an IT administrator would use. We've talked about GitOps. I really kind of didn't mention that term, but that's a term that's kind of a high-level term for how we store our infrastructure as code. And those two aspects are implemented as part of our Rancher management server. And so what that allows us to do is implement infrastructure as code that Rancher can then apply to multiple Kubernetes environments. Rancher has a component called Fleet, which allows Rancher to talk to many Kubernetes clusters. And through that mechanism, then we can apply this infrastructure as code across these Kubernetes environments. And again, that leads us towards this reusable infrastructure as code that I can easily say, yes, put that application out here in a public cloud. And I've got infrastructure that defines the policy and mechanisms I want to define how that application will run in that environment. So let's talk about some key aspects or pillars of enterprise workload portability. And a little hint, where the workload runs is just the beginning. So workload portability is really an application management issue. And so all the things that you well know about application management apply here. So this is a list of some of the key major things in application management. I'm sure if you're an IT manager or developer or IT administrator, you're very familiar with these aspects. And they include policy and security and authentication and performance and runtime, uptime and scalability and managing and monitoring the applications, maintenance of the applications, upgrades, security upgrades. So, the list goes on beyond this, but those are some key aspects of application management, and we need to address those key aspects when we think about workload portability. So let's dive a little deeper. Let's talk about some of the aspects of what we can get in a Kubernetes environment. Kubernetes has a rich set of application security characteristics. So from definitions from the kernel up into the Kubernetes stack, we can define all sorts of aspects of control over the storage and networking and encryption capabilities, API access, authentication, auditing, monitoring. So we really want to develop the same sort of best practices that we define in our kernel plus operating system security for an application. We want to do the same thing in a Kubernetes environment. Application policy really has to do with limiting the capabilities or edges, ranges, and consumption aspects of our application. So we don't want one component or one application to take over an entire machine when we have a cluster that we can share things on. And so multiple containers might run together on a machine. We want Kubernetes to have the flexibility to do that. So we want to constrain our components so that they don't errantly take over resources that they shouldn't. And some of that deals with normal security kind of things, don't let the application do that at all. And some have to do with just things that maybe the application kind of gets away from itself or has bugs and, maybe consumes more CPU than it needs to, or other resource consumption. So these are, again, part of the application policy model that we want to put in place so that when we move to other application environments, we get a very uniform characteristic of the way our application runs. So let's talk a little bit about multi-cluster Kubernetes, or the ability to have many Kubernetes clusters and to make them more uniform for workload portability. So our goal here is, again, the ability to move components and maybe entire applications around in an environment. And we want to do that based on the use cases that are most appropriate for our business needs. So that might be a private data center because we see that as being more secure. That might be the public cloud because we see that as being more flexible and perhaps less expensive for the amount of time we need it, or certainly more available in certain ways to our customers. That might be a managed service, which ties some of these capabilities together and takes some of the burden off of us. So these, again, are business characterizations that, having a tough time with that word today, that apply to our choices of the runtime environments that we want. So a little deeper then into multi-cluster management and the business decisions that drive our application runtime. So, of course, security is a key aspect always in our application environments. And so in security, as I mentioned, in these use cases, we might look at these different scenarios and try to evaluate, is a private data center really more secure than the public cloud? It may be, depends on how we do our security. So it's certainly the case that we could maybe not do security well enough, and our private data center might not be as secure as a public cloud provider could provide, or certainly we want to be able to evaluate those characterizations so that we can make good business decisions. Data governance, of course, a very important worldwide issue that we want to be able to evaluate as we move data around with our applications. So when we move in particular to public cloud providers, we want to be sensitive to aspects like GDPR that impact our use of resources in particular geographies, and we want to have compliance with the laws in those geographies. And there's a very interesting consortium that's being, or kind of government entity, and I guess it's not all government driven, but it's a consortium really of called Gaia X that's redefining the data governance in the EU. And it's, I think, really important that we continue this work to define good data governance for cloud use and for data governance across these infrastructures. As again, anybody in IT would say, yes, we need to be really conscious of data use and the governance of it. And there's other aspects that deal with our multi-cluster management and application management. And of course, that's performance and cost and scale and uptime. We want to be sensitive to all those business decisions. And I think the reason I point these out here is that they're not only business decisions, but they're things that we need to delve deeply into with Kubernetes. We want to understand Kubernetes capability and then make sure that we're defining those capabilities in infrastructure as code so that we leverage them appropriately as we move our workloads around. I mentioned before that, we've had customers say Kubernetes is the floor for me and I don't want to deal with things below that. While that's true, there's always software below that. And again, any IT administrator or manager would say, if there's software there, I need to be conscious of it and manage it in some way. And that's still true of operating systems. Even if you're working with a public cloud provider, there will be an operating system underneath the Kubernetes environment. And so you need to be conscious of it. And SUSE Manager is a great tool for helping with the typical IT application environment needs around compliance and security and monitoring and measuring. So while we want to do away with thinking about those lower levels of a stack, we also want to make sure that they're managed appropriately and in the same infrastructure as code approach. And SUSE Manager is a great tool for helping us with that. So let's kind of bring it back together in terms of the things we talked about today. Really, what we're after is a strategy for workload migration. And there's certainly technical components to what does that take, right? Understanding the software levels and stacks that we're utilizing, like Kubernetes and the operating system underneath them. And there's also business considerations of how do we implement the security and the policy that we need to make sure that as we move workloads, we get a consistent application environment so that we're comfortable that the business needs are being met appropriately. So those are really key aspects to the way we manage our workload migration strategy. And you'll see that really having a uniform application environment with similar operating systems and similar Kubernetes and tools to manage that and automated approach through infrastructure as code, those are some of the real keys to really developing a workload migration strategy. Because again, there are many choices around where a workload can run. And we as managers really want the flexibility to choose the best ones. And those really change with our business environment. And then we need to certainly understand the technical capabilities of the platforms that we're dealing with so we understand how well we're achieving the goals that we're putting in place. And I really look at multi-cluster Kubernetes as the new application management floor, if you will. Again, I always like, as a software person, I like to think about the fact that there's an operating system under the hood, because I can't ignore that, and you can't pretend there isn't software when there is. But we want to think of Kubernetes as the place where our applications run uniformly, and that it's easy to move between a Kubernetes environment. And anybody who's doing this today will say, well, it's not that easy today. We have tools. I just walked you through them, but you have to really put those tools in place and develop a strategy to really gain the benefits of the strategic approach of workload migration. And I really think this is going to be a common characteristic into the future, that companies will begin to realize, yeah, I don't want to use the public cloud all the time. I want to use it when it makes sense. And I don't want to have managed service providers all the time. I want to use them when they make sense. So the more I can make my application management uniform and easy to implement through automation, the better I can leverage those pieces of the puzzle for application management. So thanks so much for joining me today. It was fun to have a conversation about this. I hope you enjoyed it. There's a really cool opportunity at SUSECON called Brain Date. And Brain Date, just search for Brain Date. It's an opportunity to have separate conversations about technology or business or anything you want to talk about. So one thing that might be fun is set up a Brain Date to talk about workload migration, and be happy to join you with that. So thanks again, and enjoy your SUSECON.